Welcome. This video is CCBYNC. Welcome to class, everybody. Here we're going to sort of summarize everything that we've learned in trigonometry so far in chapter 1. And we're going to learn some new identities. Our reciprocal identities, cosecant, and I want to write that out. Cosecant is there, and then secant. That's the way these are written out here, secant and cosecant. Cosecant is 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta. And we can also write the others. So we can say that sine of theta is 1 over cosecant theta. Cosine theta is 1 over secant theta, and tangent theta is 1 over cotangent theta. And we're going to use these reciprocal identities often. They're not particularly difficult to do. And so let's do an example here real quick. If sine of x is 3 over 5, then cosecant of x is just 5 over 3. If cosine of x is 2 over 3, then secant is 3 over 2. And if tangent is 7, then cotangent is 1 over 7. So it's just real easy. You just flip it. Now, when we come to the identities, the actual quotient identities where we're using y, x, and r, again, the reciprocal of sine of theta is y over r. That means that cosecant is r over y. Secant is going to be the reciprocal here, r over x. And cotangent is the reciprocal of tangent, which is going to be x over y. So you can see they're kind of opposites of one another. And I want to quickly review. When we have the unit circle, like we have here, again, the radius is 1. And when I'm in quadrant 1, remember, x is positive and y is positive. And if you recall, when we're using a unit circle, x is cosine theta and y is sine theta. Which means if I rewrite the ordered pair, it's actually, instead of x comma y, it's now going to be cosine theta, sine theta. So x comma y, this means cosine is positive and sine is positive in quadrant 1. That's what we're saying here. In quadrant 2, x is negative and y is positive. And what we're actually saying is that cosine is negative in quadrant 2 and sine is positive in quadrant 2. In quadrant 3, both x and y are negative, meaning cosine and sine are both negative in quadrant 3. And in quadrant 4, x is positive and y is negative, again meaning cosine is positive, sine is negative in quadrant 4. And I'd like to point out that, actually, let's do some examples. If secant is negative 13 over 5 and theta is in quadrant 3, now again, in quadrant 3, both sine and cosine are negative. Now secant, if you remember, is the reciprocal of cosine. So it's going to follow sine-wise, S-I-G-N, the same as cosine. And we can see that secant is definitely negative there. Now, it says we're in quadrant 3. You'll notice that cosine is negative in both quadrants 2 and 3. But they've specified for us that we're dealing with quadrant 3. And what we're going to end up with is we're going to have to find a missing side here. Now, I know this triangle doesn't correspond directly to the quadrant that we're in. However, secant is the hypotenuse, which in this case is 13, over the adjacent, which in this case is -5. Now, I want to find that missing side, so I'm going to use the Pythagorean theorem. So I'll call this A. So a squared plus -5 squared is 13 squared. And I want to be clear, A in this case has to be negative because X and Y are both negative in quadrant 3. So A is a -12. So now when I find the sine of theta, that's the opposite, that's the -12 over the hypotenuse, which is 13 in this case. Notice it's negative. Cosine is the adjacent over the hypotenuse. It's also the reciprocal of secant, so we get the same conclusion, -5 over 13. Then the tangent of theta is the opposite, so that's -12 over the adjacent, which is -5, and a negative divided by a negative is a positive. So that's how we can find all three of those. Here we have our cofunction identities. All this is doing is when we use the word cosine, cotangent, cosecant, what we mean by that is, here's the connection between them. They're basically what's called a 90-degree phase shift or shift between them. And this will make a lot more sense to us when we get to another chapter where we're actually graphing these things. And that's going to make a lot more sense to us when we get to that. But here are our identities for our cofunctions. And our big ones are our Pythagorean identities. If you recall, when we're talking about a circle in algebra that's centered at the origin, and in this case has a radius of 1, the equation for that is x squared plus y squared equals 1 squared, which is just 1. Now, as you might recall, x equals cosine theta and y equals sine theta is our x and y. So I'm actually replaced the x and the y with both the cosine and the sine. So this becomes x squared, which is cosine squared theta, plus sine squared theta is equal to 1. Typically, we write it like this, with the sine squared first. This is more of a normal thing. It's not wrong to write it that way. So there is one of our huge formulas, one that we use all the time, not just in trigonometry, but in calculus all over the place. First, second, and third semester calculus. It becomes very, very useful. And we can actually come up with 2 other formulas with this. So I'm going to rewrite it. Sine squared theta plus cosine squared theta equals 1. If I go through and divide through by cosine squared, we end up with sine over cosine is tangent. So we end up with tangent squared theta. Cosine squared divided by cosine squared is just 1. And as we learned from our reciprocal identities, 1 divided by cosine is secant squared in this case. So here is our second Pythagorean identity. Our third one, again, I'm going to rewrite sine squared theta plus cosine squared theta equals 1. In this case, I divided by cosine. However, if I divide by sine squared, theta, we get sine squared theta over sine squared theta, that's 1. Cosine over sine is cotangent, right? That's the reciprocal of tangent, cotangent squared theta. And we just learned with our reciprocal identities, 1 over sine is cosecant. And this gives us our third version of our Pythagorean identities. So keeping those in mind with our example 3, if cosine of theta is 1/4, then what is the value of sine of theta? And we're going to assume that theta is in quadrant 4. Now I'm going to do this the original way that I just showed you, and then we're going to use our Pythagorean identities to do it again, and we should come to the same conclusion, of course. All right, cosine theta is 1/4, and we're in quadrant 4. Now, cosine is positive in quadrant 4. It's the adjacent over the hypotenuse. And this, I'll call that y. Y squared plus 1 squared equals 4 squared. Now, y in quadrant 4 is negative, right? In quadrant 4, we have that x is positive and y is negative. So y is going to be negative root 15. And from this, we can conclude that the sine of theta is a negative root 15, the opposite of the hypotenuse. No problem. However, I want to redo this using my Pythagorean identity. Make sure I can squeeze it on there barely. Here we go. So I know that cosine of theta is 1/4. So if I do sine squared theta plus cosine squared, cosine in this case being 1/4 equals 1. We get sine squared theta plus 1 over 16 when I square it equals 1. And when I subtract 1 over 16, sine squared theta is going to equal 15 over 16. And for those of you that forgot how to do fractions, 1 minus 1 over 16 equals 16 over 16. You should know this if you're in trigonometry, but next, I'm going to take the square root of both sides, keeping in mind it's plus or minus. However, because I'm in quadrant 4, it's got to be the negative version. The square root of 16 is 4, and you can see we came to the exact same conclusion. How cool is that? All right, I hope that was helpful.